So now for this next part, let's imagine you have recorded some data from a moving object, whether it be a car, a ball rolling down a hill, or a person walking. And you want to know, but now you've passed that data on to somebody, and all they can see is the data. Say we have 0 times 0, position 3, and that could be meters, centimeters, depending on the object that you're measuring. And 1, 3, 2, minus 1, 3, 0, 4, 0, 5, 2. So now you're looking at the data set going, well, what's going on? Well, this is where the graph comes in handy. So we can take our ruler here and we can make our graph. So we have our vertical, our horizontal, Cartesian coordinate system, x, y. And here we'll have our position on the vertical, and on the horizontal, our time. We can space out, so we have 0 to 5. So we go 1, 2, 3, 4, 5. Let's go to 6 since we have the space. Oh, sorry, yeah. And then position, we actually have a little bit going in the negative, so why don't we add a bit to that. Not perfect, but it'll do. And we'll get our ruler lined up. We'll go plus 1, 2, 3, 4, 5, minus 1, 2. Not super important that it looks pretty, but as long as you get the information across. So for those of you who say I can't draw, I wouldn't stress about it too much. So we have our origin, which is 0 here in the middle, and then we have 1, 2, 3, 4, 5, 6 seconds. We have 1, 2, 3, 4, 5, say meters, minus 1, minus 2. And then we can start plotting our points. So 0, 3. So at 0, we're at position 3. And then at 1 second, we're at position 3. And then at time 2, we're at minus 1. Ooh, I made a mistake there. Let's go back. Let's erase that point. It's okay, we all make mistakes. So again, so at time 1, we have position 3. And then at time point 2, let's say 2 seconds, we're at minus 1. So 2, minus 1. And then we can go at time point 3, 0, 4, 0, and then 5, 2. So we can get an idea what this object was doing. Draw some lines. All right, so now we can see from 0 to 1 second, the object was not moving. We have a horizontal flat line. And then from time stamp, let's see if I can have a pointer. So time stamp between 1 and between 1 second and 2 seconds, we go from position 3 to position minus 1. So we're going negative direction, and then we switch direction from negative to positive as we go from minus 1 to 0. We hold position for a moment, and then it moves from 4 to 5 seconds. It moves from 0 to position 2. So we can say some things about this. What might be the highest velocity let's say the highest speed. So the highest magnitude, the biggest magnitude would be this one here. If we just look at magnitude, it's in the negative direction, but the highest magnitude. If we want to look at the biggest positive magnitude, we have this one here. If we're looking at the slopes, how steep are the slopes? And this one here is right in the middle. And we have 2 points here and here where it stopped. So you can see how taking some data here that looks pretty random and you put it on a graph and you can start to analyze that data and see what that object is doing. So for your next activity, you're going to take, most likely for homework, you're going to take any object around the house. Maybe you have a toy car, maybe you can have a ball you can put on an inclined plane and roll it down the plane. Maybe you can have somebody walking around. Remember, one-dimensional, back and forth, but forwards, changing their speeds. Take some at different times. Take some measurements, and then you can use that to construct a position time table here. And so we can see what that might be like. So what you might do is, let's change the pencil. You might take the floor. So say that's the floor. Maybe so if you're maybe measuring a car moving in the house or a person walking, you can take that and you can use tape and mark off maybe in meters or maybe centimeters, depending on the thing you're observing. Alternatively, you can use a measuring tape to do that. So you can take a measuring tape, and this will already be marked off. Tape that to the floor, and what you can do is now you can use a camera to watch the movement, and it could be yourself, of the car moving along that segment. It could be going forward and then backwards. Maybe you have decided to do some sort of a ball rolling down an inclined plane. So that could just be a table propped up on an edge or something. Be safe, whatever you do. And say you have a ball rolling down the hill, or an inclined plane, again, marking off distances. And you can use a camera to film it, and that way you can pause and you can see as that ball is moving down, you can mark off what maybe every second where that ball is. Okay, and so you'll take that data, put it on a data table, and then try to make a position time graph. And in that position time graph, you can then analyze the movement to see, is it constant velocity? Is it positive constant, negative constant? Is it accelerating? Is it accelerating in a positive direction, a negative direction? And after that, once you've done one by hand, then we can move on next class to using data, say something like Excel, to take that data, put it into a computer program and automatically generate and analyze the graphs. But first we'll do them by hand, and then you can post the results on the Nearpod link